Hello, everyone. Welcome back. We're up to lesson 3 this time. And for this lesson, we're going to learn about a different type of sequence called an arithmetic sequence. It looks like arithmetic, but we actually pronounce it arithmetic. You might remember from the previous lesson, we learned about what we called a geometric sequence in which the pattern is to multiply or divide by the same number each time. Well, an arithmetic sequence is a similar type of sequence, except this time the pattern is to add or subtract by the same number each time. In a geometric sequence, we call that number the common ratio. For an arithmetic sequence, that number that you add or subtract each time is called the common difference. So similar concept, except different name, common difference. And we can find the common difference by subtracting any term minus the previous one. So we can take any term, subtract the previous one, and that tells us our common difference. And then if the pattern is to subtract the same number, we would say that the common difference is negative that number. So for example, if my pattern is to add 2 each time, we would say that the common difference is 2. But if the pattern was to subtract 2 each time, we would say that the common difference is negative 2. That's what I mean by that. And then the last characteristic, unlike a geometric sequence in which the graph is exponential, in an arithmetic sequence, the graph is linear. Linear sounds like line, so a linear graph has a straight line, essentially. So let's go ahead and look at the examples for lesson 3. So for each sequence, terms 0 through 4 are listed. Remember, I talked about in lesson 1 that our first term is term 0, our second term is term 1, so on and so forth. So for each sequence, terms 0 through 4 are listed. Here are our 3 sequences. So number 1, for each sequence, determine whether it is arithmetic, geometric, or neither. Determine whether it is geometric, arithmetic, or neither. If it is geometric, find the common ratio. If it is arithmetic, find the common difference. So let's start with sequence A. So sequence A, let's look at our pattern here. As we go from 30 to 40 to 50 to 60, it looks like my pattern is to add 10 because 30 plus 10 is 40, 40 plus 10 is 50, 50 plus 10 is 60, so on and so forth. So our pattern is to add, so we would say that that is an arithmetic sequence. Okay, and we would say that our common difference, if it is arithmetic, find the common difference. The common difference, which I will abbreviate CD, we're going to say that the common difference is 10, since our pattern is to add 10. So that's sequence A. Sequence B. Sequence B, it doesn't look like it's geometric. We're not multiplying by the same number. And it doesn't look like it's arithmetic because look at our differences here. We add 5, then we add 10. 5 plus 10 is 15. Then we add 15. 15 plus 15 is 30. Then we add 20. So there still is a pattern, but it's not an arithmetic pattern because we're not adding the same number each time. And it's definitely not a geometric pattern because we're not multiplying by the same number. So B is an example of a sequence that is neither arithmetic or geometric. So B is neither. And C, by process of elimination, that would mean C is geometric. But let's double check. So we say 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So yes, that is definitely a geometric sequence. So sequence C is a geometric sequence. And the common ratio is this time is going to be 2, since our pattern is to double, to multiply by 2. Number 2, if the patterns you described continue, in which sequence is term 10 the largest? Now, there's a couple ways we can do this. We could legitimately go through and find each of the terms of the sequence and figure out which one has a larger term 10, but that might take a while. The key in this case is that A is arithmetic and C is geometric. Remember, an arithmetic sequence, remember from the notes, an arithmetic sequence has a graph that is linear, and a geometric sequence has a graph that is exponential. Notice they're both increasing. A and C are both increasing, and so is B. The question is, which one is increasing at the faster rate? So if we think of the graphs, which type of graph increases more quickly? A linear graph or an exponential graph? And the answer is exponential. An exponential graph always increases at a faster rate. So if the exponential graph increases at a faster rate, that means the geometric sequence that goes with that will also increase at the faster rate. So without even having to find any more terms, I can say without a doubt that sequence C is going to have the largest term 10, okay? And that is because it's geometric. Anytime you have a list of sequences and you want to know which one is increasing at the fastest rate, it's always going to be the geometric sequence. And it's because it's exponential in nature. So that's number 2. Number 3, what can you say about the differences between consecutive terms in sequence A? So we kind of already answered that. In sequence A, the differences between consecutive terms is going to just be 10. It's always going to be 10, right? Because if I take any term and subtract the previous term, the difference is going to be 10. 40 minus 30 is 10. 50 minus 40 is 10. 60 minus 50 is 10. So what can you say about the differences between consecutive terms in sequence A? We can say that the difference is always 10. Number 4, what can you say about the differences between consecutive terms in sequence B? Well, this one's a little different because 5 minus 0 is 5. 15 minus 5 is 10. 30 minus 15 is 15. 50 minus 30 is 20. So the differences between consecutive terms is increasing by 5. The difference is 5, then the difference is 10, then the difference is 15, so on and so forth. So to answer question number 4, what can you say about the differences between consecutive terms in sequence B? We can say that the difference increases by 5 each time. Meaning I add 5, then I add 10, then I add 15, so on and so forth. And that is it for lesson 3.